The Red Sea spans over 2,200 kilometers, masking a massive geological trench that plunges more than 2,200 meters into the Earth, an environment of extremes. Thousands of years ago, according to ancient texts, millions of fleeing Israelites found themselves trapped between this lethal expanse of water and the charging cavalry of the Egyptian pharaoh. The narrative states that the waters suddenly separated, carving a dry corridor right through the sea. This allowed the refugees to cross before the liquid walls collapsed onto the pursuing army. For centuries, scholars read this account entirely as supernatural theology. The idea of an ocean physically splitting in two defied every known law of fluid dynamics. But dismissing the event entirely ignores the possibility that a massive natural atmospheric anomaly occurred on that specific day. Finding out requires looking for concrete evidence buried under the waves.
In 1978, underwater explorers diving along the Red Sea's floor reported finding physical anomalies scattered in the deep sand. They uncovered what appeared to be gold-plated chariot wheels. Researchers analyzed the specific 4-spoke and 6-spoke designs of these wheels and found they matched the precise engineering of Egyptian chariots from the exact era of the Great Exodus. While archaeologists still heavily debate the authenticity and origins of these specific artifacts, the discovery forced a pivot in how we analyze the ancient text. If we treat the ancient account as a physical event rather than magic, we have to answer a very specific physics problem. Is there a measurable, natural mechanism capable of forcing an ocean apart? In 2010, a team of scientists at the National Center for Atmospheric Research approached the ancient text exactly like a fluid dynamics dataset. They built a computer simulation to test extreme weather conditions against the exact underwater topography of the Red Sea region. This animated diagram demonstrates a recognized atmospheric phenomenon known as wind set-down. It shows how intense, sustained gusts can exert enough shear stress on the surface of water to physically move large volumes of it over a shallow landmass. The researchers programmed the model with a relentless wind blowing from the east at exactly 100 kilometers per hour, pushing directly against the water over a known shallow ridge. The sustained force from the simulated storm displaces the massive volume of water backward. A completely dry land bridge emerges in the center, flanked by thick, stacked walls of water held rigidly in place by the wind. The modern fluid dynamics model perfectly replicates the exact mechanical description of the event documented in the ancient texts. Physics dictates a strict limit on this phenomenon. A land bridge created by a wind set-down is highly unstable, relying entirely on the constant, unwavering pressure of the storm. This timeline overlay in our diagram reveals the strict mathematical calculation produced by the simulation. It shows the exposed pathway would remain open and dry for a maximum window of exactly 4 hours. The human stakes would be incredibly high. A fleeing population carrying whatever they could grab would have to cross that exposed ridge against a relapse the surface tension instantly breaks. Millions of tons of displaced water violently rush back into the gap to find its natural level. The rapid, overwhelming return of the ocean provides a physical explanation for the sudden destruction of the pursuing cavalry. The science completely aligns with the historical record. The NCAR study confirmed that parting a sea is entirely physically possible under extreme, naturally occurring atmospheric conditions. That shifts the investigation. The focus is no longer on how the water physically moved, but rather the statistical anomaly of exactly when it happened. A 100 km/h wind set-down event is incredibly rare. Having it strike precisely as an enslaved population was backed against the shore, with an armed military force right behind them, is a staggering statistical coincidence. Supercomputers and atmospheric modeling can easily break down the wind shear and fluid dynamics of the event, but science cannot calculate an explanation for that flawless timing. Rigorous scientific analysis doesn't always debunk ancient accounts. Sometimes it confirms the physical mechanics of those events, leaving the Red Sea as a shifting, living environment that still holds some of history's deepest mysteries.